I just wanted to use the video, a video to just to go through the exam questions in case some of you are finding it hard to do them. So the first question that you had here, it said that natural gas or methane burns in oxygen to produce carbon dioxide and water. Now the first thing I want to just show you here is look at reactants, products. Reactants are the substances that react together. The products are the things that are made. So you're making carbon dioxide, you're making water, you're reacting methane, and you're reacting oxygen, okay? Now, they have drawn the atoms for you there in different colours. So they're using the yellow there to represent the carbon atom, the reds are representing the oxygen atoms, and the blues are representing the hydrogens. And they've asked you to count, essentially, and to count the number of atoms in the reactants and the number of atoms in the products. So carbon, so you have one carbon atom there, look, in the reactants, and you have one carbon atom in the products. Hydrogen, you have 1, 2, 3, 4 hydrogen atoms in the reactants, and you have 1, 2, 3, 4 hydrogen atoms in the products. And for oxygen, then you have 1, 2, 3, 4 oxygens there, and you have 1, 2, 3, and 4. You have 4 oxygen atoms there as well. So it tells you then in part B that mass is conserved. Conserved means it's kept. And you have a definition for law of conservation of mass, which means that the mass is the same in the reactants and the products. What evidence does this diagram give you for law of conservation of mass? Well, if you've got equal numbers or the same numbers of atoms in the reactants and the products, then the mass is going to be the same. Okay, so you just have to say that there are the same number of atoms in the reactants on each side, if you like. Same number of reactant atoms, same number of product atoms. If you had 2 carbon atoms over here and only 1 carbon atom over here, then you would not have conservation of mass. Okay, the last part then says the burning of methane is an example of a chemical change. Describe one difference. Now you have a definition of a chemical change and a physical change. A physical change is where there is no new substance made. A chemical change, yes, you do have a new substance made. Okay, so that's our difference, right? So that's that question. Now, this question here then, that you were asked to do, it says to write a hypothesis for the investigation. Now, lads, you need to read your questions carefully. So they've told you that sodium chloride is a white crystalline solid, that water is a solvent, okay, with a boiling point of 100 degrees, and it says sodium chloride can dissolve in water. And then it asks you to write the hypothesis for the investigation, that the student was asked to investigate the effect of adding salt on boiling point of water. Now, if I was you, I'd be thinking boiling point of water. Now, they just want you to write any kind of hypothesis at all. So, but you are supposed to base it on scientific knowledge, do you remember? So it's explanation of what you think might happen. You don't have to be right, but what do you think might happen? But you must try to base it on some sort of scientific information or scientific knowledge. Now, what do we know about boiling point? We know that the boiling point is where you have a liquid turning to a gas, okay? Now, if you can think about the particles of a liquid, how are particles of liquids arranged? Well, they're a little bit spread from each other. They can move around slowly. Gases, however, are very spread out. Do you remember? So you have to give energy or heat to the particles of a liquid so that they can move faster and move further away from each other and behave as gases. We would have done a PhET simulation. I'll actually copy the link for that for you on Edmodo later. But we did a PhET simulation. I showed you that when we were in school. So you have to heat the liquid particles, give them energy, sufficient energy that turn them into gases. Now, I hypothesize that by adding salt to the water, is going to somehow make it harder for me to separate the water molecules, or to allow the water to behave more like gases. So if the water is going to turn to a gas, its water molecules have to spread apart from each other completely. And I think it's going to be harder to do that if you add salt. So what will happen to the boiling point? If it's harder to separate the molecules, I think the boiling point will increase. So you would write a sentence explaining that, okay? Now, What is meant by boiling point? Well, that's your definition. Boiling point is the temperature. You must have that word temperature. Like if you were asked for the units of temperature, you'd say degrees Celsius. So it's the temperature at which liquid changes to a gas. Throughout the liquid, not just the surface of the liquid. You need that word throughout the liquid. And don't be tempted to say water there either. You need the word liquid, because you can have, you know, there's boiling points of other liquids like ethanol or different liquids, not always water. So it's the temperature at which the liquid changes to a gas throughout the liquid. The instrument there, you all know that's an electronic balance, okay? And now finally there they asked you to draw a label diagram of the arrangement of an apparatus that would use to determine boiling point. So you would draw a beaker on a hot plate. You must label everything. So beaker with water in it, of course, on a hot plate. And you'd also have to draw a thermometer, because you need to record the temperature at which the water is going to boil. Okay, so that's that question. Now the second part of this question here gave you some data, and it asked you to calculate the average boiling point when 4 grams of salt. So look, you just have to add up there. You have, they repeated it 5 times there, 106 and 107, divided by the number, which is 5. And when you do that, your answer comes out at 105, okay? Now, it says, suggest a reason why the student might have repeated. Now, we never repeated 5 times. If we were ever doing repeats, we would have repeated the investigation 3 times. But why? Why are you repeating the investigation 5 times there? You're repeating it to get an average. Now, what's the advantage of receiving averages or getting averages, calculating averages? Well, it improves the accuracy of your investigation. So to improve accuracy of your result, you would repeat the investigation and then calculate averages. Now, does the data support your hypothesis? Now, I wrote in my hypothesis that as I increase the mass of salt that I add to the water, that my boiling point would increase. And does it support the data? Yes, my hypothesis does support the data. And you'll have to, remember I was saying to you in school to use data. So I would say something like, with no salt, the boiling point is 100.6 degrees Celsius, whereas when you added 8 grams of salt, the boiling point increases to 109.6. So use your data to back up your statements, okay? Now, this question here then, you have a very funny looking periodic table, but you must be able to kind of manipulate the information that's given to you. Now look at the colours. The red shows that there's a serious availability, its availability is being threatened. Rising threat to availability. Green is plentiful, so you need to match the colours. So from the table, identify a gas. Now, your periodic table, we would have divided it up into metals and non-metals, okay? The top right-hand corner would be where you would have your non-metals. And generally speaking, we would have said that non-metals would be gases, okay? Do you remember we talked about properties of metals? We said that they have high boiling points, high melting points, they're generally solid at room temperature, they conduct electricity, but the non-metals then would be the opposite. So if I'm looking for a gas there, which is a component of the Earth's atmosphere, which is in plentiful supply, you need to look at the greens, and you need to just to know what's a gas. Okay, like sodium, potassium, calcium, they're not gases, they're solids. They're all to the left-hand side. So look up at the top of the right-hand side there, you see oxygen, you see things like nitrogen, neon is there, argon, they're all gases, okay? And they're all green, so they're in plentiful supply. So just one of them would be fine. B then asked you, why should you use the gas helium in Bertha B avoided? Now, why should we not find helium? Helium is He, so you have to know that helium is He. Look at it up here. Look at the colour. So what would you say? Why should we try to avoid using helium? Because its availability is seriously threatened, okay? And then for C, look, they say the element indium. Now, they're telling you it's In, so you can look now and you can see from the periodic table that In, it says, is... If you look for it there, you can see that it's again the red, so its availability is being threatened. So state one way that we could contribute to sustaining the levels of it. It's used in smartphones. So remember we're at the sustainability chapter. So how can we sustain the levels of idiom that we're using, so we can't use as much of it, so we can't be making as many smartphones as we want, if you like. So you're going to have to maybe recycle the idiom in smartphones. Maybe you upgrade your phone less often, so you're not buying a new phone as often, something like that, okay?